today we're going to review finding slope 4 different ways. Slope, remember, is represented by the variable m. It represents the rise over run. It's also change in y over change in x. Also the vertical change over horizontal change. It's a rate of change. It tells us how two different quantities change with regard to each other. When we use the formula, it's y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. There are 4 different ways, 4 different situations in which we can find slope. The first one is from a graph. So if we look at this graph over here, this graph has a line. On this line there are many points. There are no points designated, so we have to put some on. So this is a good place for a point. It's a good place for a point because it's where the 4 grid boxes meet. This is also a good place for a point because it's where all 4 of the grid boxes meet. In order to calculate the slope of the line, we're going to look at the change in y, or the vertical change, and the change in x. So I'm going to see what happens to my line if I start at this point and I travel up my grid line and then I travel to the right to the other point. So I went up 2 boxes. Alright, so up 2. I'm also going to travel to the right. 1, 2, 3, 4. So that means that I went right 4 boxes. Up and right are both positive directions. So my slope, I'm going to write positive 2 over positive 4. Because remember, the vertical change comes first. That's always in our numerator. I can reduce this. Positive divided by positive is a positive number, and 2/4 becomes 1/2. So that's my slope. You can change this to a decimal, but for right now we like to remember that there are 2 movements going on. There's a vertical change, an up and a down thing, and a side to side. So we like to see the fraction. So most often slope is written like a fraction. The second way to look at slope is to use the formula. And the formula is that y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay? So in each point we have an x and a y coordinate. In order to use the formula, it's a good thing to designate those and to figure out which one is my x and which one is my y. So in my first point, I make this x sub 1, my second one, y sub 1. So I have 3 is my x sub 1, negative 4 is my y sub 1, because it's my first point. 6 is my x sub 2, and negative 7 is my y sub 2, because that's my second point. The 1 and the 2 only designate which point it is. We're not doing anything mathematical with those. Now we take those points, those numbers, and we substitute them into our formula. So we start with y2. y2 is negative 7 minus y1, which is negative 4. Please don't drop your negatives. In the denominator, we have 6 minus 3. You may also want to connect them. So the negative 7 goes to the negative 4. They are both the second numbers in each of those points. And the 6 and the 3 are also the first part of those points. So those are my x numbers. Notice that 6 and 3 is in the denominator, negative 7, negative 4 is in the numerator. When I calculate this out, negative 7 minus negative 4, or negative 7 plus 4, remember that becomes plus, is negative 3. And 6 minus 3 is 3. I can simplify that to be negative 1 over 1. That tells me to go down 1 and to the right 1. Down is a negative motion. Okay? And it's as simple as that. That's our slope. The next way we're going to talk about is from a table. From a table, you can actually do the same thing as we just did. You could use the formula because each of these makes a point. This is negative 4, 4. And we have negative 2, 7. Those are points. So we could use the formula that we just did. The other way that we can look at slope from a table is to actually calculate our changes in x and our changes in y. So if I look at my changes in y, we have a positive 3, because to go from 4 to 7 is plus 3. From 7 to 11.5 is plus 4.5. And from 11.5 to 20.5 is plus 9. This is my change in y. That triangle means change. I also want to look at my change in x's. So I'll do the same thing over here. From negative 4 to negative 2, I increase by 2. Negative 2 to 1, I'm going to increase by 3. And 1 to 7, I'm going to increase by 6. This is my change in x. I also want to pair these up because I have to calculate my slope using the parts that are comparable. So this 3 and this 2 come from the same 2 points. So that slope is 3 over 2. Okay? I'm also going to look at each of the other comparable ones. So here I have plus 4.5 and I have plus 3. So my next one is 4.5 over 3. And guess what? If you simplify that, you'll get the same thing as 3 over 2. So we're good so far. The next piece, I'm going to look at the 9 and the 6 just to make sure that I have a linear function here. So I get 9 divided by 6. And if I reduce that, I also get 3 over 2. So we're good. Our slope is 3 over 2. And we have a linear function because the slope increases the same all the time. For the last thing, we have slope from an equation. If you'll notice, this equation is written in slope-intercept form, and that's y equals mx plus b. M is our slope. It's always the coefficient of x. So our slope is this coefficient here. And it's as simple as that. Slope is negative 4/3. This also tells me, because it's negative, I can have the negative either with the 4 or I can have it with the 3, but only with one of those two. If I have it with the 4, that means I'm going to go down and to the right. If I put the negative with the 3, that means I'm going to go up and to the left. So be careful which way you put your negative. Bring any questions that you have to class.